right, let's start usual way. I started this way in Brazil last year too. Let me find if I can do this. All right, cool. This is my conference selfie. So as you can see, this is actually, if you zoom in from the middle one, this is last year in Brazil. So cool. Where look at how many people, no masks. It's amazing. And this is the world now. So it's more conference selfies, but definitely more not as cool, but still tradition. So I'll keep. The good thing about conference selfies now is that it's completely inception. So you can see there's going to be more and more and more selfies within each other. Cool. Okay, enough crap. So let's talk about libraries. That's what I'm going to talk about today. And I want to preface this by saying that a lot of the stuff that I want to talk about here comes from experience, but it was really hard to put into words. So I think I'm gonna be hand wavy a lot, and I think I'm gonna be, like philosophical sometimes, more practical sometimes. We'll see how it goes, because the stuff is that it was hard to put on virtual paper, not just in my head and in experience. So let's see how it goes. Anyways, I'm Andrea. That's what you hide is my username on the internet. A few of you may know me because I spoke last year at ElixirConf. Maybe I saw you, I have no idea. I have no list of attendees anywhere that I can see. I'm speaking just to my screen. So hopefully a bunch of people who were at Elixir Brasil last year. I'm a member of the Elixir core team. I've been a member of the team now since 2016, so almost 5 years. And I do a lot of open source in the Elixir world and conferences and blogs. And I'm even writing a book on testing Elixir now, but I don't want to jinx anything because I can't seem to finish this book. So I'll just not talk about it. That's my strategy. Cool. I work at a company called community.com, which does communication at scale. Means basically we provide the community leaders with tools that they can use to communicate with their audiences in a one-to community way. So instead of texting one-to-one or texting one to everyone or sharing one to everyone, like social media, this is more share one to community. It's very cool. We are hiring, and if you want to go, you can go to community.com and check it out, or you can send me a DM on Twitter if you want to hire. We're hiring a lot of roles, so there's a chance that everybody gets their role as a position there. What are my credentials to talk about libraries? In open source, I have a bunch of pretty active libraries in the Elixir community, including Redux for Redis, gettext for translations, stream data for property-based testing. I contribute to Plug and a bunch of more libraries, and these are all libraries that are over in the millions of downloads. So they've been pretty widely used, hopefully pretty widely bottle tested as well. And at work, I kind of do similar things, which is that I maintain libraries, Elixir libraries that we have that are shared across now more than 40 Elixir services, which is crazy to think about for me. But we have a few libraries, core libraries that are shared among these services. We'll talk more about those later, but there are things that power our event sourcing system. So they're the backbone of our stuff, like our event sourcing system, logging, error reporting, all that sort of stuff goes into libraries that are shared by all these services. So that's what we do at work. And the thing that I want to talk about today is writing libraries, and especially with the focus on the contrast between writing open source libraries and libraries that are general, that are meant to be shared by anyone, right? But just meant to be shared by people that write code, versus libraries that are used internally in companies. So libraries that are meant to be used inside a company that are business specific and so on. And these kinds of library, open source, I'll call them open source libraries and internal libraries. They have very, very, very different requirements. So I'm going to focus on my kind of experience and tips on writing open source libraries and writing internal libraries, and what are the differences between the two approaches, basically, and what each kind of library is meant to be used for. So I will start quickly with an overview of the use cases so that we can get an idea of what I'll be talking about, and then we're going to go with more tips and more philosophical stuff about writing open source and writing internal libraries. So let's start with the use cases for open source libraries. And so the probably first one that comes to mind is to share code. And important for me is to share non-business specific code. So usually the reason you write an open source library is because there's a piece of code that you want to not have people write all the time, and that is general enough that a lot of people are going to need it. So think of a database driver. For example, I wrote Redux, which is a Redis database driver, and that's a general piece of code that anyone that's going to interact with Redis, regardless of what they're going to do with Redis, can use that piece of code they can use that library to not have to write the code that interacts with Redis and the code that encodes the protocol and all that stuff. So that's definitely I think the main use case of open source library, to share non-business specific code. Then it's, I think, to share what I like to call plumbing code. Especially this, I think this is especially useful in open source, is to share code that is not very arguable, like a database driver. So there's not a million ways to write something like a protocol serialization code. Like you wanna decode and encode the Redis protocol. That's not very arguable. It's not gonna be, oh, I want to write it with this design, I want to write it with this other design. It's mostly going to be pretty similar. And the nice thing about abstracting that sort of code into a library is that it's just code that it's not very all people can contribute to, and all people can make better and can make the best possible, Redis protocol encode and decode code out there for Elixir. So that's the beauty of making it open source and having people contribute to it and read it and scrutinize it and just make it better. And then another use case of open source libraries is to build abstractions. So when you want to, generally, this is kind of an umbrella thing, but you want to build an abstraction over some piece of code, and you want to tell people how to use abstractions and kind of put people on some rails that they're going to follow to do something. So that's a good use case. And finally, provide building blocks. So when you write a library, you want to usually provide kind of building blocks that people can compose to then write their own business specific stuff, right? And the building blocks, need to be general enough so that they can actually be shared by people, regardless of what their business code or the business requirements are. But the idea is to provide these building blocks that people can compose to build their own business code. So this is open source libraries. Internal libraries are a little bit different. They have some similarities, but a lot of the practical approaches to writing internal libraries are very different, and the use cases are different as well. And the main use case of internal libraries, I would argue it's kind of similar. It's the abstraction of still non-business code. If you're abstracting something that's very business related into a library, there's a chance that maybe in a lot of cases, in my experience, that's a service rather than a library when you want to share some functionality. So for example, if you have business code that's related to manipulating users in your system, you probably want to abstract that away into an isolated service rather than into a library, because that's not really, in my experience, the purpose of sharing or abstracting away the code. It's more abstracting away the functionality itself. But abstracting non-business code internally is still very important. For example, say that you have a mechanism to generate IDs across your whole system. So it could be some form of like UID and something else combined with it. Then that's definitely like specific to your companies, and it's probably private. So it makes sense to share it, but it makes sense to not make it open source, but at the same time, it's not something you want to write in every single service, right? Or it could be logging code, it could be instrumentation code, all sorts of stuff that you want to share between the components of your system, but that you don't want to, so that you don't want to repeat across all the components of your system, but at the same time that you don't want to share open source because it's still part of your intellectual property if you want, right? And another really important use case, I think, for internal libraries is to steer engineering organizations in a direction. So usually when, in my experience, when you have an engineering organization, especially one that's growing, you want to keep engineers kind of rowing in the same direction, and you want to keep them writing code that is mostly similar to this one, like, you know, as similar style as possible, similar patterns and abstractions and design principle as possible. And libraries really, really help with that, because you can encapsulate, often you can encapsulate a lot of the decisions that you make as an engineering organization into libraries that then people can compose into, for example, services by, you know, using the libraries in the services and being guided by the libraries in how to build, how to follow the conventions of the engineering organization. And I touched this a few times now, but another thing that I really believe internal libraries make possible is to have microservices, right? So I don't think that you would have an easy life if you had microservices and no library, no code shared between them, right? So it's not necessarily libraries, but if you want to share code between, if you have microservices, I think that you need to probably share code between them. And when you want to share code, I think libraries are the best way to do it. So as I said, this also comes from personal experience, where at work now we have more than 40 services and written in Elixir, and they all need to share some code. For example, they need to share some code for reporting errors. And instead of re-implementing that in every single service, we decide, okay, let's extract this in a library and share the library across all our services, right? So I'm going to talk more about what to abstract and how to go into abstracting the right things for internal libraries later on. But I think that they are really essential. They have become an essential part of our system and our microservice or services-oriented architecture, and we wouldn't be able to do what we're doing now without, you know, having a bunch of libraries driving the code in the services. So let's now I'm going to talk more about open source and internal libraries in their different aspects. I'm going to start with open source, and I'm going to talk about the goals when designing open source libraries, and then I'm going to talk about some practical tips when you're writing open source libraries. I realize that not a lot of people end up writing open source libraries, but if you do, I think this is super helpful to have. Because these tips are helpful. They would have helped me a lot. This is stuff that I learned with years of experience writing libraries. And I'm going to then talk about the same things for internal libraries. So I'm going to talk about the goals and then some practical tips for writing internal libraries as well. And I believe that internal libraries are much more common to write, because if you're working at a company that has a bunch of code bases and needs to have some parts of those code bases abstracted and shared across the code bases, that's an internal library usually. And I think that people, since they don't write enough, well, not enough, but they don't have the chances to write a lot of open source libraries, then they don't take the principles of writing the open source libraries into writing the internal libraries, because a lot of stuff ends up being really similar and, you know, kind of on the same wave. Okay, so let's start with the goals of abstractions in open source software. And I'm going to just list a few and talk about those for a bit. For some stuff, I'm going to have more practical examples. For some stuff, it's just things that I think about when writing libraries, but I'm not always capable of putting into practice on specific concise examples where I say, okay, all this principle, here's where it applies. So I'm just going to talk about those if that's the case. And the first one, this is the thing that I like the most about abstractions in software in general, especially open source libraries, is that the principle that easy things should be easy and hard things should be possible. I think this has helped me so much. And the meaning of it is that when you're writing some abstraction, you really want to nail the level of abstraction where you're writing the library to share some code so that people don't have to write that code. So you want to make the easy things that you should do with that code, you should make them easy. So for example, you're writing a database driver, you want to make it easy to do queries with the database driver, right? Because that's kind of one of the main things that you want to do with a database driver, and one of the easiest things that a database driver should do. It can do more complex stuff like, I don't know, like a connection pooling and all sorts of like transactions and stuff like that. But one basic functionality is queries. So you want to make executing queries easy. It can use the complex stuff underneath, but from a user-facing perspective, you want to make something like that easy. On the other hand, the hard things that you want to do with some, for example, like a database driver, you want to make them possible. You don't want to block them out for the user, right? So when you're writing a database driver, for example, you want people to be able to access the pooling functionality, right? Or you want to have people be able to do something like do transactions based on top of queries and stuff like that. So you don't want to close the level of abstraction so that users can't do hard things, but you don't necessarily need to optimize for hard things in your API, right? So when I design an API, what I usually try to do is that I try to design an API where the easy things that one should do with the library are easy to do in the API. The hard things that you may want to do, maybe I don't cater for those I don't optimize for those in the API, right? But I rather just not make them impossible. So I say, okay, if you want to build proxying on top of this, we'll go build it yourself. Here are the building blocks, right? Because it's going to be hard to make an easy API to do something hard, because the use cases become more complex and so on and so on. So easy things should be easy, hard things should be possible. And when I'm writing an open source library, I also focus a lot on things like flexibility and utility and clear abstraction levels. Flexibility, I mean that the library needs to be flexible enough to accommodate most use cases, so that I don't just cater to a small group of users, but I try to capture as many people that would need functionality as I can. The utility is important as well. This is non-trivial, but your open source library should be useful for something, right? So a lot of time I see people, I come across libraries that are arguably maybe not so useful, or they are so small that it would be easier to just write the code directly optimized for your specific use case. So you need to strike the balance between the library is doing something useful and is doing enough that I would want to pull in a library to do it, right? And then clear abstraction level, this is also important. So I usually would try to write a library that is consistent in the abstraction level. And what I mean by that is that if I'm writing, for example, again, a database driver, I try to just strike the balance between having a database driver that allows me to do database stuff, but I don't build bigger abstractions on top of it and put them in the library as well. So I wouldn't build something like a DSL on top of the database driver, right? And if you think about Act, which most of you are probably familiar with, that's exactly the case, right? You have several layers of abstraction, and all the libraries, and they are built into libraries, and those libraries have exactly the clear levels of abstractions, right? So you have, for example, Acto at the top, which has the DSLs, the migration stuff, so lots of very high-level abstractions to work with databases. And Acto is built on top of database drivers. So think of Postgres for Postgres. And Postgres doesn't provide any fancy stuff like DSLs. It just provides basically connection pooling and protocol and serialization and deserialization. So it essentially allows you to just talk to the database, but then you have to tell Postgres what to do with the database. You don't have any higher level abstractions. And Postgres itself is built on top of DB connection, which is a database connection pooling library. So whose job is just to provide pooling abstracted from the specific things that you're trying to pull. In this case, it's database connections. So all of these libraries respect this clear abstraction level where they are not trying. So you're not building, for example, Postgres, where you're building a database driver and then you're putting also DSL on top of it. No, like the abstraction level is clear and it's just talking to the database. So hopefully that makes sense. It's I think something that's it's very common in open source, but it's hard to kind of nail it and put it into words. But a lot of libraries are doing this, so that's good news. Another thing that I try to do when I build open source library, one of the goals is to provide escape hatches. So anytime you're building an abstraction on top of something, there's a chance that you don't want to block any functionality that's under the abstraction. So for example, say that you're building, the usual example for me is a database driver, but say that you're building a database driver, there's a chance that you're talking to the database through TCP or SSL socket. And if you completely obscure the socket from the user and don't allow the users to provide options, for example, to interact with the socket, to connect and to communicate over the TCP or SSL socket, then you're going to run into troubles, because you're going to find at some point a user that has a specific requirement where they need to set a weird SSL option to do some stuff, and then you don't provide this escape hatch where the user of your library can add or can access the underlying layer of abstraction, and then you're gonna have problems, because those people then can't use the library at all, even if using the whole database driver for to be useful, for example, right? And an example that I like of this is the fragments in Ecto. This is exactly the kind of thing where Ecto built a nice DSL where you can do a lot of stuff already in the DSL, but sometimes like they don't want to build every single possible thing that every SQL database provides, like, I don't know, functions like lower or you know, all sorts of things that databases provide. I can't think of anything else. Call as, you know, to concatenate strings, all sorts of stuff that you want to do in the database. And providing something like Ecto provides this DSL on top of it, but instead of trying to cover all possible things that you can do with the database through the DSL, they cover the most common things, and then they provide the escape hatch of having a fragment so that you can send strings directly to the database, right? And it still provides value over using the database directly, because it provides, I mean, aside from the serialization and deserialization level, it still provides validation of, for example, the number of arguments. It provides, it blocks SQL injection attacks and all this sort of stuff, but it lets you access the functionality provided by the database, right? And this example, I really like it because it also really nails the principle of easy things should be easy, hard things should be possible. So if you're doing easy queries where you say select the star from users where user.id equals something, Ecto provides the DSL for that, right? And it actually provides even easier functions on top of that, because that's kind of one of the most common things that you want to do, right? So it provides functions for doing greater than or lower or less than. It provides functions for doing, you know, also selecting parts of queries, all stuff that those are the easy things to do with a database. Right, but hard things like doing, I don't know, here is not very hard, it's just lowering a string. But if you wanna get the fields that have resulted in a conflict in a query, that's stuff that the database exposes through SQL, but Ecto would have trouble exposing through it. It would have a huge API if you wanted to expose all this sort of stuff through built-in functions, right, and the built-in DSL. So those are hard things, but they should not be easy necessarily, so you shouldn't necessarily provide the DSL for those two, but they should be possible, right? You don't want to block those. And this is exactly what fragment is. It's like, it's a hard thing that is possible. It makes hard things possible. So you have weird stuff in your database, it just gives you an escape hatch so that you can use and do the hard things. But the easy things, they're covered by the DSL, right? So his things are easy. The hard things are possible. So I really like this example for this principle. Hopefully makes sense. And then another thing that one other goal of, I think, of when designing open source libraries is to figure out whether your library is an idea library or a plumbing library. So this distinction, I started thinking about this actually maybe 3-4 years ago, but it always stuck with me. Of this distinction between idea and plumbing libraries, where idea libraries are frameworks for how to solve problems, and so they're not really solving the problem of writing complex, error-prone, tedious code and packaging it and testing it for you and giving it to you. That could be, for example, like a network protocol. That's definitely what I think of as a plumbing code. So it's not something that complex code that I want to share. But idea libraries instead, they give you a framework to solve problems. So for example, Phoenix is what I would call an idea library, right? Or Phoenix is a good example. This is a library that doesn't provide a lot of hard, error-prone and hard-to-write code. But what it does, the value that it provides is that it provides you with a common language for writing web frameworks, right? And common abstractions for writing web frameworks. And writing a clone of Phoenix that's bare bones, it would be a small thing. It's not a really complex library. The real value I think that it provides is, I don't know, Phoenix is a large library, so it also solves some problems for sure, but the biggest value that it provides, I think, it gives you a vocabulary and it gives you a mindset when you're working with web applications, so that we have a common language, and we have a framework to write a web application. So those are idea libraries, and I usually compare them with plumbing libraries, where the thing that we do that they do is that they solve, I like to call them non-arguable problems. So again, these are problems that it's just code that's like nasty to write, and you just want someone to write it once and test it and get it battle tested by the community, and then you're good. So that library works and you don't have to write it in all your applications. So because if you imagine that, what if you wanted to write database code and network protocols when you want to interact with the database in every service that you write or in every application that you write, you go nuts, right? So you want these problems to be solved, but it's hard to argue, oh, I would have encoded I would have written the encoding for this protocol differently, or usually it's not very arguable. Like there's usually like hard facts that tell you, oh, this is just a better version, this is not a better version. And the nice thing about having that code shared is that people can contribute and can make the best possible version. So for example, Postgres, like database driver for Elixir, has been public for 6 years now, and the code has been scrutinized by a lot of people. It has been improved, and there's no point, I personally think there's no point in writing another database driver, because we reached like probably what is one of the best approaches that we can have in Elixir to interfacing with Postgres protocol. So that's where we are. It's not really arguable code. Something like Phoenix, something like generally an idea library is very arguable, because you can say, oh, I think that the schema and context and controller and view is crap. Like that sounds crazy, and it's a valid point. It's not it's not easy to measure the impact of, oh, this is the right abstraction, whereas it's much easier to measure, oh, this is the right implementation of protocol serialization and deserialization, right? So I really like to make this distinction. And when I'm going to talk about tips for open source library, the first thing I'm gonna say is optimize for the right kind of library, optimize for the right, optimize for whether you're writing an idea library or a plumbing library. So what I try to do usually is I don't try to stick ideas and frameworks, and I don't when I'm writing a plumbing library. So for example, Redux, which is definitely a plumbing library. So it's a library that's just meant to provide you with an interface to Redis without doing fancy stuff or without providing fancy abstractions on top. I stick to that. I don't try to make to say, oh, this is how you should use Redis. This is how you should think about Redis databases or Redis commands or when to use the pipeline. No, that's just a plumbing library. I give you the tools to say, oh, this is how you execute a command. This is how you execute a pipeline of commands, just a few things. And then people can reason about that and can write their own implementations and their own abstractions and their own ideas on top of that, right? If you try to write an idea library instead, I try to really impose impose the structure of how people should use the library, and maybe try to make the plumbing pieces of the library composable and pluggable, so that the focus of the library is really providing the ideas, right? And generally, another advice that I like and that I take myself is that when there's a hard abstraction to write, so for example, if you're can't figure out if your library is an idea library, it's because it has some framework parts, but also some lower level parts. So if you have this kind of hard abstraction to figure out, what I like to do is say drop down to the lower level of abstraction. So for example, in Redis, for a long time, I said, oh, should I write a pool for Redis, or other than on top of the connection handling and the protocol handling? But then I never figured out a nice implementation of the pool. Some people would want maybe some checkout pool where you check out a single connection at a time. Some people may want a kind of registry-based pool where you just pick connections and share them between processes. So there's different implementation, and I never figured out. And what I said is, okay, I just drop down to the lower level. I just provide you with a tool to start a connection, and then try to do my best to provide you with tools so that you can build pools on top of this, right? And this goes back to the building blocks aspect of open source libraries, right? I try to provide all the necessary tools so that you can build whatever abstraction you want on top of the library, but I don't try to impose anything. So I drop to the lowest possible level of abstraction that I know is gonna make things flexible in general, but still useful. So I think that's the case. Another tip, this should be a no-brainer, but I still see it done in practice sometimes, is to not have any global stuff in your open source libraries. So by global stuff, I mean anything that's a global resource in the library. So it could be named resources, it could be anything that the library that cause problem if the library is used by two times in the same application in different ways, for example, right? So if Redis registered every connection with a name, then you couldn't use two connections, right? Because it's a global thing, and you really usually don't want any of that. And an example of this that I think applies to the no global stuff umbrella of things is to write libraries that don't have an application supervision, that don't have a supervision tree that's in the library. So some libraries in Elixir and Erlang, what they do is that you have your application with your supervision tree, and then the library starts its own supervision tree. And then when you want resources from the library, it manages them under its supervision tree and gives access to them in your application. This is an example of this is how the AMQP client, so the RabbitMQ client for Erlang works, is that it has its own supervision tree, and it starts connections under its own supervision tree and gives you access to those. But that makes it really hard to manage lifecycle of stuff. It really makes it hard to manage resiliency when you're using this library from different parts of your code base that have different requirements for reliability and resiliency and so on. And the right approach to this in Elixir and Erlang is definitely to have the library build the supervision tree that you need and give it to you so that you can put it inside the supervision tree of your application or under the supervision tree of your application, right? So you have one single supervision tree for your application, and a part of it is this library supervision tree, which can be as complex as the library needs, as long as it's pluggable under your supervision tree, so that you can then manage the life cycle of this supervision tree, the resiliency and the resilience and error handling requirements of that part of the supervision tree. You can manage those yourself. And part of the no globals is also to not use named resources in open source libraries. Not use by named resources, I mean like naming a process, registering a process, something like that, and not using application environment. A lot of libraries read configuration values out of the application environment for that library. The problem is that if I want to configure those values differently when I'm using the library from two different parts of my code base, I can't, because the application environment is global. So that's a bad idea, in my opinion. If you need named resources, if you need to access the application environment, if you want to provide users with access to the application environment for configuring the library, the good approach for me is to require a name when the users are using your library. Require the users to use a name for the resources they're creating, and then build on top of that. So a really good example of this is Broadway. So when you start a Broadway pipeline, you have to pass a name option, and the name option is going to be used by Broadway so that the resource that you're creating has a name, and plus Broadway can create a lot of other resources that are also named so that internally can do routing and registering processes and stuff like that. But it can base all of those resource names off of your name that you created, right? So if I started the pipeline like that, I went to the observer to look at this revision tree that Broadway generates, and you have this very cool thing where you have all the way on the left, you have elixir.pipeline. That's a resource that I named. And then Broadway uses that name to create a whole bunch of processes. You can see you have elixir.pipeline.broadway.supervisor. Then you have pipeline.broadway.battery supervisor down there. You have all sorts of resources that are named, but they all named starting with the name that I gave. So the library was able to create named resources and make use of those, but at the same time, it's not spamming the global namespace, right? Another thing I want to talk about that are really important, I think is really important, is logging and instrumentation. And in open source libraries, I think now finally we have a standard. So you want to do any logging on instrumentation, don't in your open source library. Instead, just use telemetry. So telemetry is a library for essentially emitting events that then users can consume and handle by plugging event handlers into telemetry. And so when you want to execute an event, it just looks like a function called telemetry execute. The first thing is the event that you execute, and then you have some measurements and metadata and stuff like that. And I think open source libraries should only exclusively use this for anytime you want to do logging and anytime you want to do instrumentation. So instead of writing logger info, emit a telemetry event with that same information. Right? Instead, every time you want to measure something and report the time that it took somewhere, use telemetry instead and emit the telemetry event to say how long this thing took, right? And one thing that I really like to, so this is the part where it says like hard things should be possible. So users that way can do anything they want. They can log they can write handlers that take your telemetry event and log them by, I don't know, like writing them in the snow with some, hot water. It's super weird stuff. You can do whatever you want, right? So you can cover all use cases. At the same time, easy things should be easy, right? So what if users just want normal logs when a Redis connection goes down, for example? They just want to log, hey, connection went down because of this reason. Then what I like to do is to provide default handlers for telemetry events. So, for example, Redis ships with this. You can attach a default handler that catches the telemetry event that are emitted by Redis and logs through normal logger. It logs some information, right? So you have at least a basic functionality that just comes out of the box, so that if you don't have any strange or fancy requirements, you can have a plug and play experience. In my experience, when you're starting with a project or when the companies are young and stuff like that, it's really useful to have this sort of stuff because you really don't want to go and write your telemetry handler to, I don't know, funnel logs into your, logger aggregator of choice. You don't want to do any of the weird stuff. You just want to use logger. So provide a default handler. And then when you have the necessity that maybe you're growing large enough, or you have the necessity to write something more complex, then you can write your own handlers, right? And in Redis, it's really simple. We have, just to show you how it looks like, it's a telemetry module that has a attach default handler function. And you can just call this when starting your application so that you use the default handler. And it attaches to a bunch of events, and it calls the handle event function that I define in Redis telemetry. And this handle event function just logs the event with the right level. It's really not important to look at the code here, just showing you how, the idea is that it's really easy to provide these default handlers, and they cover the easy things should be easy part of the library design, right? And the hard thing should be possible part is that you're emitting events in the first place, and so people can write any kind of handlers that they want. And the last thing I think about open source libraries that I want to talk about is extensibility. And extensibility is a I mean, a really important principle when you're writing open source libraries, especially because you want to write libraries that people can extend and can use in ways and in use cases that you couldn't even imagine when you were writing the library, right? And one example that I like about this is mix shell. So if you ever wrote a mix task, maybe you know that if you want to write something to the terminal, probably the best way to do it is to just use mix.shell.info. That shell has parens because it's a function call, because it returns a mix.shell returns the current mix shell that you're using, and then mix provides a few different shells that you can use, where the default is IO. And that's the one that when you write mix.shell.info, it writes a message to the standard output. If you write mix.shell.error, it writes it on the standard error. And so it's a default. But you can also use, for example, mix.shell.quiet, and that's going to swallow anything, and it's not going to write. So the code that you write is still mix.shell.info and a message, but nothing's going to be emitted by anything. That shell is just going to make it quiet. Mix.shell.process just sends a message to the current process instead of printing. This is very useful for testing. But the principle here is that if you provide these extension points, then you can write code that's very generic, and people can use your library to write very generic code, and then they can plug in different abstractions. And even the library can come with some of those abstractions to extend the library. Right, and the last thing was not this, but it's versioning. So this is really important. There's not a lot to say about this, but if you're writing an open source library, really think about versioning. There's only one proper versioning system, in my opinion, which is semantic versioning. If you go to samver.org, that's where the spec is. It's just a way to define versions where a version is made of three parts. You have the major, minor, and patch part. So the major part is the first one. If the library has any API changes that break the previous usage of the library, you bump the major version. So you will go from 1 to 2 in this case. The minor version is used for new features. So if the library introduces new features but doesn't break backwards compatibility, then you bump the minor version. And the patch version is you don't break any backwards compatibility, but you fix bugs. So if you fix something small, it's pretty straightforward, very, very useful. Hex, the Elixir's dependency manager, works on top of semantic versioning. So libraries are required to have semantic versioning. Elixir is semantically versioned. All Elixir libraries from the Elixir team have semantic versioning, so usually pretty common now, but definitely something to do when writing the library. Cool, so those were tips for writing open source libraries. It's a big collection. Hopefully you were able to pick some that maybe you thought about before and make sense now, or to pick some stuff that you can use when producing this sort of libraries. More, I think, common use, again, a more common chance to write libraries when you're writing internal libraries instead. So let's talk a little bit about those. And I want to talk about the goals of the abstractions in internal libraries, right? And I think they can be summed by saying that I want an internal libraries to be aggressively opinionated on abstractions and tooling. So you want to be be very decided and not make things very general and very flexible, but rather opinionated, so that the code that your company produces internally has the great benefit of looking the same, which has all kinds of benefits where people can move around in the company. You can take pieces of code that don't belong to your team, for example, and read them and understand them as well. You can use some common tooling and abstractions. So I think it's much more valuable in internal libraries. And in general, when I design an internal library, I give more importance to ease of use rather than flexibility. So I actually usually don't want people in the company to be able to use the library in very different ways, so to make it flexible so that it can be used in different ways. Because in my experience, that's counterproductive to having the library in the first place, which is to abstract some design and patterns and code and functionality abstraction in a very opinionated way, right? So I try to make things easy and one way and provide one way to do it, right? So that's also very important. One way to do one thing. So in open source libraries, that's not usually the case. I don't worry about that so much, because if the API is flexible enough, there might be different ways of doing the same thing, and people can adapt to which way makes more sense to in their own context. In internal libraries, I much prefer that there's a single way to do one thing, so that the code is going to look as similar as possible. Even if you lose a little bit of flexibility, you gain, you know, understanding in the team, I think. And I think a thing that I strive to do also when writing internal libraries is to make the right thing easy to do. So the right thing should be the easy one to do. It's kind of a general principle. I like that people, that when I write internal libraries, I like that people have to do something strange to screw up, and I don't kind of set up traps in the library so that it's easy to screw up. So I try to make the natural thing to do, I try to make it the right thing, or vice versa, rather. I try to make the right thing the natural thing to do. So kind of hard to capture, but it's something I try to think about. And then I want to talk about the role of internal libraries and why we write internal libraries in the first place. For me, the biggest, again, is like having something opinionated. So it's having uniform code, which leads to easier collaboration. That's something that I just mentioned. But the value of having a code that looks the same across different code bases, different services, in my experience at my place of work right now, it's been invaluable into aligning the engineering organization into writing code that people are able to contribute to, people are able to take code from another team and understand it. It's extremely valuable to have this uniform code for collaboration. And then a bunch of tips for writing internal libraries. So they're going to be a little bit maybe less than the open source libraries, because a bunch of the open source one apply as well, but they're going to be the specific ones that I focus on when writing internal libraries. The first one I really like is that if you have your application and you have your library, and applications build abstractions on top of the internal library, then probably my feeling is that the library is not abstracting enough. So whenever I see this structure in the code in our system, I say, oh, I need to put some abstraction in the library. So the orange box need to go inside the purple box, because I want, if people are building abstractions on top of the library, then there's a chance that we want the library to provide those abstractions, right? So that the code is going to look more uniform across services and so on and so on. So this is something that I try to actively avoid. So if I see this pattern, I just include the abstraction in the library. Usually it goes better that way. A thing that I use a lot in internal libraries is use, the Elixir macro use. So for example, if I'm writing an internal libraries, I'm going to make the example of a made up internal library that's a Redis pool built on top of Redis. So I would probably write something like this, where you can write in your service, you can write def module my service Redis, and you do use Redis pool, and you provide some options. That gives me a lot of benefits when writing internal libraries, which are like doing something like compile time check, so that you check that people are using the library in the right way at compile time. Allows me to do kind of convention over configuration. So it allows me to make the code look exactly the same and configured the same way, instead of making its usage flexible. It provides practical benefits, like a reading from the app environment without using globals, and I'm going to show that in a second. And it also allows me to define common APIs by injecting code, which is something that I would probably not do in open source, but it's really helpful for me in internal libraries, because it allows me to provide the same exact API for people using this library, right? They don't have to build abstractions on top of this. This is the example of configuration that I was talking about, where you have, in this case, you're configuring the app. So for example, there, configure my service. That's an app that you're configuring, and then you configure the specific module there where you call use. And that's very nice, because you're not using the global configuration of the library, you're using the global configuration of the app, which is fine, because the app, you're running one app, but you're still able to use the the application configuration, which has a bunch of other benefits. So if you're curious, that's kind of how it would look like in this case. So you inject functions like, I don't know, command takes a bunch of strings and then picks a connection in the pool and then uses Redis underneath to execute a command, right? But for people that are using this, you just call Redis pool.command. So you call, or write, or rather myservice.redis.command, right? In the example that I made. Logging and instrumentation in internal libraries, that's a completely different question. I think that's a completely different matter. I think that's where one of the biggest differences are. I really like to have opinionated logging and instrumentation in internal libraries. So our system right now looks kind of like this, where you have many services. I mentioned this, but like maybe 40 or 45 services, Elixir services, and all of them use a few libraries, maybe 3 or 4 or 5, depending on the use case. And the libraries use loggers and instrumenters. We use specific tools for logging. We use Elixir's built-in logger. We have a syslogger backend so that we can funnel logs to our logger aggregator. And then we use a single instrumenter, which is UpSignal. But hiding those behind the library, it's very useful because it allows us to potentially switch those things like the logger and instrumentation in very few places and have the services use like adapt to that. And at the same time, we can be opinionated and make sure that all services use the same tools, right? And another thing that I really like that I talked about now is that the open source model. So a lot of what we talked about, I try to make in internal libraries as well. Not much in the system, in the library design, but rather in the usage of the libraries. So for example, semantic versioning, that's something we absolutely use in our internal libraries because it allows us to have scenarios like this where we have different services running on different versions of the libraries. And as long as the things that the library does are compatible so that they're not breaking the usage of the library across services, then you can update, you'll release a new version of the library and you don't need to go and update all services, which is time consuming and everything, but it's rather a pretty quick process where you can just release the library and then tell people, hey, when you have time, update the library in your service. And the services can coexist with different versions of the library, right? Another thing that we borrow from open source is publishing our libraries on Hex. We use a private hex.pm account, so where we go and publish the libraries. It's been super stable. We never had problem with this actually. And we also use it for documentation. So Hex provides private documentation for private libraries. So we use this as well. We have for example, a bunch of docs. This is for an internal library that we have. They just look like they're generated with Xdoc. They just look like open source docs. Been super useful. Another thing that I can show practical examples from our stuff that I really like to focus on is test helpers. So when I write the internal library, I really try to provide people with tools and utilities to make testing code that uses the library easier. And the principle that I try to live by is to test the library in the library, not to make everyone test the library when they're using it. In open source, I don't really do that because you can use the library in very different ways. So I say like, just, you have to test the way that you use it. In internal libraries, I try to be more flexible and say, more opinionated and say, this is how you test that you're using the library correctly. And then the library code is tested in the library. And then I want to make a final shout out to a tool that we use for managing libraries that we use for other things as well, but we use for managing libraries across many services, which is Shepherd. And this really kind of sealed the deal on how we use internal libraries. And this is a tool that lets you write, essentially, you write some code that can make PRs, that can change code and make PRs to a lot of repos at once, right? And it's very programmable. Very flexible. So you write a YAML file, that's a Shepherd file, that's what it looks like. And this essentially has a branch name in there, title to the PR, and then you say, okay, and another adapter is GitHub, and you provide a search query for GitHub. So for example, you say, oh, search all the repositories from my organization that have the mix.exs file at the root of the project. And this is really cool for us because, for example, this means get all the Elixir the mixed projects that our organization has, right? So this will pull in your computer like 60 projects, and then it runs some hooks that say, oh, for example, should I migrate this? And for us, this means, oh, you want to migrate services, and you have, I don't know, like you search for the release directory or the rel directory. If it's there, it means it's a service. And then I want to say grep, like for example, this is an example of a Shepherd migration to upgrade Elixir from 1.9 to 1.10. So I say, is this an Elixir 1.9 service? I just grab Elixir 1.9 from its Docker file, and so it's yes. So essentially, the idea is that if this should migrate steps tell yes, then I can migrate the service, and then you apply some script. For example, in this case, it's a script that would do a bunch of sed to replace the Elixir version in a bunch of places, right? And it doesn't really matter what I'm doing here, but what I want to show is that this is programmable. You can do whatever you want. You can filter repositories, and then you just do a bunch of stuff. You do Shepherd checkout, you check out all the repos, you apply your changes, you commit them, you push them, and you make a PR. And you can do this within 5 minutes. For us, you can make a PR to, 50 services, and this is huge because it allows us to, then teams can take care of merging and deploying the PRs, but it allows one person to make a change to all our services really, really easily, right? And this is allows us to manage library upgrades, and this really sealed the deal on having the shared code between all the services with the libraries, because you can upgrade libraries very easily across all the services, right? So we're generally almost on the same version of the library across all services. So that's really cool. I wanted to give a shout out to this tool. Cool, some quick recap for open source and internal libraries and how I try to design those and what are the principles that I try to live by when designing those. So open source libraries, I want them to be general and flexible. I want to think about whether they're plumbing libraries or IDEA libraries, if that makes sense. The stuff that I try to focus on for internal libraries is just focus on convention over configuration. So try to make things that look the same as much as possible. Try to make strongly opinionated library so that people use them in the same way, and so that people write uniform code. Let our system and our engineer organization be aligned, and try to provide the built-in plug and play tooling. So you usually don't need to think about logging and instrumentation. If you start the library and start using it, then it does the right thing for our system. So in our case, uses the right logging tool, the right instrumentation tools, and all of that. And that is just in time. I ran slightly late for questions, but maybe we can have some time. But that's all. That's a show. Thanks.
Awesome. Wow, what an amazing talk. Thank you so much, Andrea. It's been like
My pleasure.
a ton of wisdom delivered this morning. So.
It's a ton of stuff. I apologize for that. It's as I said at the beginning, it's a lot of stuff, and it's really hard to put in practice and to put into a lot of practical tips as well. So hopefully, if you could pick some stuff here and there. And I'm always open for questions, and I want to write a blog post on this. So hopefully, I'm going to be able to present the ideas more. This was just a very, philosophical, sentimental way of presenting this.
Absolutely. Yeah, I have some questions myself, but anyway, I can speak from my own experience that applying those concepts in practice have been like a really nice journey so far. So I think we are onto something with this stuff, and there's still lots to discuss. We've been collecting some questions from the audience.
Yeah.
There you are. So hey Andrea, we've got quite a few questions. So I'm just gonna try to display them here in the overlay. Let's see if it works. Mm-hmm. So let's start with Adolfo's question. Yeah. So what library would you like to see in the Elixir ecosystem? So what is missing?
Good RabbitMQ client for sure. or rather, like if we fixed the one that we have in Erlang. That's one that I personally miss a lot, and that's a good question. I think that I don't know about any outstanding libraries that we're missing. There's a lot of stuff that we have, luckily.
Cool.
Yeah.
Let me check what else we've got here. So Felipe is asking, when you build some tool software, the best approach is to avoid adding some dependencies. So how we can define if we should add a new dependency or build a solution on our own. So yeah, build or buy when we're talking about dependencies.
That's a very good question. I think it depends on a bunch of factors. It depends on how much, it's a compromise. It depends on how much time you have to build stuff. Generally, I like building solutions if it's justified. And for example, if you're launching, if you're a tiny startup and you need to launch a product, then I would probably optimize for speed and not optimize for maintainability and correctness. But otherwise, for example, at our company now, we're at a stage where we're big enough that we can afford to work on internal tooling and internal libraries a bit more. And in that case, I would I'm very careful before adding. I consider very carefully whether to add new dependencies or not. And the things that I consider are also how long it would take for us to build this, how long, how well maintained it is. So for example, the MQP client I was talking about, it's, I think, an architecture that doesn't sit very well with Erlang, and I think they want to fix it as well. But the alternative of writing a RabbitMQ client from scratch is basically unfeasible for most companies. I would say it's like a really hard project, really hard to get it right. And in that case, by using the existing solution, even if it's not optimal, is it's for us, for example, it still makes much more sense than trying to write our own. When it's something small, I like to, when I can, to write our own solutions. And it depends on a lot of things. It depends on how finicky the things that you have to write is, how hard it is to get it correctly, how much you think it needs bottle testing. If you think it needs a lot of bottle testing, I like to go with built-in solutions. But yeah, so my mantra is try to keep dependencies to a minimum, unless you have good reasons to not keep them to a minimum, to add them. Hopefully it makes sense.
That's good. Yeah, I totally agree. Yeah, we got to get smarter when we have to make these hard choices. And so
yeah,
taking all the factors into account, it's good.
Yeah,
advice.
And the cost of just in general, the costs, also the cost of removing the library. If if 1 year from now you realize that it should have been better to write a solution, for example.
Yeah, that's true. So I think we got one last question, one more leaning to the personal side. So Daniel is asking, how much weight did you lose? I suppose this is about some new sports.
No, I think it's literally lost almost 20 kilograms of physical weight. Maybe I look thinner. I don't know. Yeah, a bunch.
That's very nice. Congratulations.
Thanks for noticing, I guess. I don't know.
Cool.
All weights are fine.
Yeah, so I think this wraps it up for Andrea.